Welcome to today's lesson. Yes, we are talking on surd, still on surd, but today's lesson is going to be on arithmetics on surds. So by the end of this lesson, you should be able to perform simple arithmetic operations, addition, subtraction, multiplication, and division on surds. Now, in the previous lesson, we already learned how we can express our surds in a basic form. We also learned how to identify surds. We also learned to compare to see if two surds are similar or not. So the knowledge we learned in the previous lesson, we are going to be finding it useful in this lesson. So let's begin. Now, it is important we know that two surds cannot be added or subtracted if they are not similar. So both surds, they have to be similar. And remember, we look at the radical parts. Just to refresh your memory, root 3, root 2, or let's say 4 root 3 and 2 root 2, they are not similar because the radical part for this is root 3, the radical part for this is root 2. They are not similar. So there's no way we can add these two surds together since they are not similar. All right, so let's get started. So it is important to know that root A plus or minus root B, it is not the same thing. Please note, I have root 3 plus root 5. Note, it is not the same thing as saying root 3 plus 5. No, that is wrong, right? It is only when we are, remember the rules of surd we looked at in the previous lesson, that's when we can say that root 3 times root 5, yes. If it is root 3 times root 5, yes, it is root 3 times 5. But if it is addition or subtraction, no, it is not. Also, if I have root 10 minus root 2, we cannot say it is not equal to root 10 minus 2. No, that will be incorrect. Okay. So that being said, what happens in the case where I have 3 root 8 plus 3 root 8? Okay, let's do something very simple. I'm trying to explain this part. Now, 3 root 5 plus 2 root 5. Now, they are similar. We should add them, right? Since the radical parts are the same. So what you just have to do is you add the real parts. What do I mean by the real parts? What I have here, 3 plus 2. Yeah, so we have 3 plus 2, then we have root 5. So, of course, that gives us 5 root 5. So that's what you have. That is 5 root 5. I hope that is clear. Okay, so let's simplify the following. So just like we do, I would have the first one, we'll do the second one together, then the third one, you will do the third one. So root 3 plus root 3, the first question is, are they similar? That's the first question. Are they similar? Yes, they are similar. Looking at the radical part. Then there comes the challenge. It is important to know that 3 root 3 is like saying 1 root 3. So it's like saying 1 root 3 plus 1 root 3. Remember what we did here when we needed to do this. So we add the numbers we have outside. That's the real part. So 1 plus 1, that is 1 plus 1. Then we have our radical. We have the radical part, which is root 3. So that gives us 2 root 3. I hope that is clear. Okay, let's see. We'll do this together. 5 root 7 minus 2 root 7. First, are they similar? I believe you said yes. Good. So since we know they are similar, then we can subtract. 5 minus 2, that's what we have. Then the radical part, 7. 5 minus 2, that gives us 3 root 7. So this answer is 3 root 7. So you do this. 8 root 15 plus 3 root 7. What do you have? Pause the video and attempt it. Okay. Do you have an answer? First, are they similar? Root 15. Can we express root 15? Is it in the basic form? That's the question. 15, 1 times 15, 3 times 5. We cannot simplify that further. So that is in the simplest form or the basic form. So 8 root 15 plus root 3. It still remains 8. Since the radical part, root 15 and root 3, they are not the same. So we cannot add the two surds together. So that is the answer. We'll leave it that way. So it means 8 root 15 plus root 3. So it is like you having to add up, let's say 8x plus y. There's no way you add that up, right? So it remains that way. Now let us look at this together. 5 root 3 plus 2 root 2 minus 3 root 3 minus 2 root 2. So if we look at this, we can see that we have some surds that are similar. We should be able to bring similar surds together. By doing that, I can have 5 root 3. What's a similar surd to this? It is this. So now do not forget the sign. It is minus 3 root 3. Okay, then the next one, that's plus 2 root 2 minus root 2. So I decided to bring the similar surds together. So 5 root 3 minus 3 root 3. What do you say? Okay, so you just have to subtract 5 minus 3 since they are similar. So that gives us 2 root 3. Now what about this? So now we have, pay attention to the sign. Plus 2 minus, now this is like saying minus 1. There's an invisible one actually. So it is, we have a minus 1 root 2. So if we do that, so 2 minus 1, it is 1. So that's plus 2 minus 1 is 1. So that's plus 1, but we do not write the 1. So plus 1 root 2. 2 root 3 plus root 2. Can I add them together? No, you cannot add them together because they are not similar surds. Is that clear? Okay, so let's see the next one. 8 root 5. You have to do this. So pause the video and attempt it. Okay, were you able to figure it out? Let's see what you have. 8 root 5. Let's find, let's bring the similar surds together. So we have 8 root 5 minus 15 root 5. Yes. Now I have minus root 3. Remember, it is like say minus 1 root 3. Yes. Minus 5 root 3. So we have these two, the first two surds are similar. So 8 minus 15. That gives minus 7. So I have minus 7 root 5. That's what you have. Minus 7 root 5. Now, do not do the mistake of having to write minus, then root 3 minus 5 root 3. Then you are saying it is maybe minus 4 roots, whatever. Now that will be wrong. What do? You have to pick this sign together with it. So it's like saying minus 1. There's a minus 1 there. So I'm having minus 1 minus 5. That gives minus 6. So it is minus 6 root 3. Now, can we add this or can we subtract this? No, we cannot because they are not similar, right? But I can choose to factor out the minus sign. Right? If I factor out the minus sign, that gives us minus 7, that's negative 7 root 5 plus 6 root 3. So is that we have an answer this way, or we have it this way, right? So we still have the same thing. Okay, so still on addition and subtraction of surds. Let's see. Now with this, are we able to say if these surds are similar or not? Looking at it, we may not be able to tell, except we put the surds, we express the surds in the basic form, in the simplest form. So we need to do that for each of the surds, and that will make the work very easy. Let us start with 4 root 18. We know that 4 root 18 is equal to 4 times the root of 18 is 9 times 2, right? And that gives us 4 times, remember, that is root 9 times root 2. So root 9 is 3. That's 4 times 3 times root 2. So we know that 4 times 3 is 12, which is 12 root 2. So we can say that 4 root 18 can be expressed as 12 root 2, yes, minus, now what is root 200? What is root 200? That's quite simple. But let me quickly do that again. So root 200 becomes root 100 times 2. Now, root 100, that is 10. Okay, let's do it this way. Root 100 times root 2, which is equal to root 100, that is 10 times root 2, which is 10 root 2. So root 200 can be written as 10 root 2. Now, plus, so what do you think 3 root 50 will be? You pause the video and give the answer to that. Okay, so 3 root 50. We can have 3 root 50 as this. 3 times root, 2 numbers are multiplied, that is 25 times 2. So that is equal to 3 times root 25 times root 2. And that is equal to 3 times, now root 25, that gives 5 times root 2. So 3 times 5, that gives 15. 15 times root 2 is 15 root 2. So we know that 3 root 50 can be written as 15 root 2. Now looking at this, the question is, are they similar? Yes, they are similar. The radical part says root 2, root 2, root 2. So it means they are similar. So we can now have 12 minus 10 plus 15, right? Or we can choose to do it one after the other. So what is 12 minus 10? That gives 2. 2 plus 15, that is 17. So I have 17 root 2. So it means the answer to this is 17 root 2, which is in the simplest form. Okay, so with the knowledge of what we have done, I need you to attempt this. Root 800 plus root 200 minus 2 root 32. So it is important to ask if they are similar. We need to check if they are similar. If they are similar, we should be able to add them. So root 800. Pause the video and attempt it. Okay. So doing that, root 800 in the simplest form can be written as root 400 times 2. root 400 times root 2. We know that gives us root 400 is equal to 20. So 20 times root 2 is 20 root 2. So root 800 can be written as 20 root 2 plus, now root 200, that's quite easy. So that is 10 root 2. I believe you know how we got that. 10 root 2, because 100 times 2, then square root of 100, that's 10 root 2, minus, now 2 root 32. We know that 2 root 32 can be written as 2 times root 16 times 2, which is 2 times root 16 times root 2. Now, root 16 is 4 times 2. 2 times 4 is 8. 8 times root 2, that gives us 8 root 2. So that's what we have. So looking at the radical part, we can see that all of these surds, they are similar. In that case, 20 plus 10, that gives us 30. So we have 30 root 2. So 30 root 2 minus 8 root 2. Sorry, I omitted the root 2. So 30 root 2 minus 8 root 2. We know that gives us 22 root 2. So that is the answer. So the error I made earlier, that makes me want to give this problem. What if I have 5 plus root 5? Do you think we can add this together? The answer is no. We cannot add this together because we do not have the radical part for this. So 5 plus root 5 remains 5 plus root 5. All right, so let us move on to the multiplication and division of surds. Now we already looked at the rule in one of the rules in the previous lesson. It is still applicable here, except that I would like to say what we looked at in the last lesson, where I remember we gave something like this: root A times B is the same thing as root A times root B, which is correct. But now let us put into consideration the case where I have 5 root 3 times 2 root 4 as an example, right? Now, this is multiplication. So we are not looking at the surds to check if they are similar or not, since this is multiplication. So we should know that 5 times 2, based on what we are doing, what we have here, so it gives us 5 times 2. Then we can now have 3 times 4. And that gives us 5 times 2 is 10. Root 3 times 4 is 12. We can simplify this. I believe you know that. 10 root 12 can be simplified as what? What do you have? Okay, this is 4 times 3. 12 is 4 times 3. Square root of 4 is 2. 2 times 10 is 20 root 3. I hope that is what you got. Okay, so that's for the multiplication. And we also dealt, excuse me, please. And we also dealt with the case of the division. So let's solve problems. Let's simplify the following. Root 2 times root 5. So that gives us root 2 times 5, which is equal to root 10. So that was quite simple. Okay, another thing is, for the case of the second problem we can always simplify our surd. We have our surd in the basic form. So if we have our surd in the basic form, it makes it easy for us to multiply. In this case, of course, we can decide to do root 25 times 45. But you see, we're having large numbers. So what do we do in this case? We can decide to, what is root 25? Root 25 is 5 times, now root 45. Root 45 is not in the basic form. So if you want to put root 45 in the basic form, what will it be? So you should attempt that. Okay, so it is 3 root 5. I believe you know how we do that. So in the case where you have this is not addition. If it was to be addition, we cannot add, but it is multiplication. Remember, this is the same thing as saying 5 times 3 times root 5. So we can easily say 5 times 3 is 15. Then 15 times root 5 is 15 root 5. I believe that was clear. I believe that was clear. Okay. Let's see the C parts. 3 root 10 times 2. Okay, I choose to write this as 3 times root 10 times 2 times root 5. So I can write this as 3 times 2. 3 times 2 gives 10. So now I have 10 times root 10 times root 5. Now, based on the rule, we know that it is the same thing as saying 10 times 5 gives 50, right? But we can simplify 50. That is 25 times 2. So I can have it as 10 times root 25 times 2. Now, root 25 is 5. 5 times 10, which is 50. So I have 50 root 2. This is quite interesting. So 3 root 10 times 2 root 5 gives us 50 root 2. I hope that was easy enough to do. Okay. So with that, let's see if we need to multiply surds of this nature. So we have 2 root 5 minus 3 root 6. Now, all multiplying root 5 minus 2 root 6. Now, you should remember how we expand the brackets of a into brackets, let's say x plus y. Now, this multiply this, then this multiply this, right? So that becomes ax plus ay, right? So the same thing, if we now have to do a plus b multiplying x plus y. Now we know that we use a to multiply everything I have in here. That's a will multiply x plus y. Then b will also do the same thing. That's plus b multiplying x plus y. So we can now expand this just like we did here. Then we also expand it. So we'll be using similar knowledge. Okay, so let's see what we have. So 2 root 5, let's bring it out. So we can say 2 root 5 multiplying root 5 minus 2 root 6. Yes, that's the first. Then the second one will be the second term, which is minus 3 root 6 multiplying root 5 minus 2 root 6. So let's see what we have. So 2 root 5 multiplying root 5. So that is, we're having 2 root 5 times root 5. And that is 2 times root 5 times 5, which is 2 root 25. I believe that is easy enough. So we know that 2 root 5 times root 5, that gives us 2 root 25. Yes, we can still simplify this, but let's older. Now, 2 root 5 multiplying 2 root 6. What do you think we have? 2 root 5 multiplying 2 root 5 multiplying 2 root 6. Remember, it's 2 times 2. That is 4 root 5 times 6. That is 30. Right? So I have 2 root 5 times minus 2 root 6. That will be minus negative 4 root 30. Right? Then let's open up the second part. So negative 3 root 6 multiplying root 5. That gives us what? That is negative 3 root 30. Then the next one, now negative will multiply negative, and that becomes positive. So 3 root 6 times 2 root 6. 3 root 6 times 2 root 6. 3 times 2, that is 6. 6 root 6 times 6, that is 36. So we have 6 root 36. Okay. So with that, we know that root 25 is 5. So 2 times 5, that gives 10. Minus 4 root 30. Since we cannot simplify 30, 2 times 15, we cannot, 15 is not a perfect square. 3 times 10, none of it is a perfect square, right? So, but we know that we have negative 4 root 30 minus 3 root 30. So we know that gives negative 4, that's minus 4 minus 3. Since these are similar, they are similar surds, the radical parts are the same. So negative 4, that's minus 4 minus 3, that gives us minus 7. So that's minus 7 root 30 plus, now watch this, root 36. We know square root of 36 is 6. Now, 6 times 6. 6 times 6 gives 36. So it means it's 6 root 36 is the same thing as 36. Now, this and this, they are the same. So I can say that 10 plus 36, that gives, 10 plus 36 gives 46. So I can have it as 46 minus 7 root 30. Okay? I hope this is clear enough. All right, so with what we've done, I would like you to try this. I would like you to try work on the E. 2 plus root 5 multiplying 3 plus root 5. And let's see what you have. All right, so with that, we can now talk about the division of surds. Division of surds. It's actually very, very simple. Right. Now I'm going to be using the rules we looked at earlier. Root 12 divided by root 3. Recall, root A over root B is equal to, we can have it as root A over B, right? So it means I can have root 12 over 3. I can have it as, so I can have root 12 over root 3. I can have it as root 12 over 3. You see, that saves me so much of stress. I do not have to express root 12 in basic form before solving. So that gives us 12 divided by 3 is 4. So I can have root 4. And we know that the square root of 4 is equal to 2. So it means this is equal to 2. Quite simple, right? Okay, can you attempt the second one? Pause the video and attempt the second one. Okay. Were there challenges while solving this? Let's see what you have. So root 24 divided by root 50. All right, I can decide to write this as root 24 over 50. Then I think, is there a way I can simplify that, the fraction in the simplest form? So expressing that in the simplest form, I divide this by 2, I divide this by 2. So that gives root 12 over 25. Okay, then I think, is there a way I can move forward? Yes. Recall the rule again, so I can express it as root 12 divided by root 25. Remember that? So that is equal to, now root 12 in the simplest form, right? That's 12, that's 4 times 3, root 4 is 2. So I can have it as 2 root 3. I believe you know that root 12 is the same thing as 2 root 3. Divided by, now square root of 25 is 5. So we can have our answer as this, 2 root 3 divided by 5. Or I can have it as 2 over 5 root 3. It's still the same. Okay. I need you to attempt, pause the video, attempt the third question, the G. What do you do? Okay. You were able to work it out. Let's see. In this case, the first thing that comes to mind is, how am I able to express these mixed numbers in improper fraction? Right. So if you're able to do that, I have 601 parts is the same thing as 25 parts. That's 25 over 4. Now back to the rule. Remember, back to the rule. So we know that it can be expressed as root 25. It can be expressed as root 25 over root 4. Okay, so let's see the case where we have to deal with this. 4 root 18 divide 2 root 2. First, let's simplify. We know that 4 root 18 is the same thing as 12 root 2. So do you agree? Yes, because root 18 is 9 times 2, and square root of 9 is 3. Now 3 times 4, that gives 12. So 12 root 2. So we can have this written as, 12 root 2 over 2 root 2. Now, this is quite simple. We can just decide to root 2 cancels, take away root 2, and 12 divided by 2 is equal to 6. Or we may choose to do this, saying 12 over 2, then root 2 divided by 2. Now, we know 2 divided by 2 is, that gives us 2 divided by 2 is 1. Square root of 1 is 1. So that still gives 6 root 1. That's still the same thing. Right. So, our answer is 6. Quite simple. What about this? What do we do in this case? Yes, let's simplify. I put the surds in their basic form. That makes it very easy. Root 60 in the basic form, what will it be? Now, we know root 60. Okay, you probably think of simpler numbers. You can, if you find it difficult to get a perfect square and a number. So we know 60 is, we can say it is 2 times 30. Then we can further split 30. That is 2 times 30 is 2 times 15. Now we know that 2 times 2 is 4. So we can simply write it. So root 60 can simply be written as root 4 times 15. So root 60 can be written as it is root 60 is equal to root 4 times 15. And we know that root 4, that is 2 root 15, right? So I can have root 60 as 2 root 15 times, now what is root 180? What will it be? Root 180. So root 180, we can still go by the same approach, saying 2 times 90. Then I can further break down 90 to give us 2 times 90 is 2 times 45. You see that? Now, this gives us the square root of 4 times square root of 4 times 45. But I can further break down 45. Breaking down 45 gives us 9 times 4, right? You know, this gives 4 times 9, 9 times 5, sorry. So 4 times 9 times 5. Now, that makes it easy for us because 4 times 5 is 36, which is a perfect square. So it means I can have root 180. I can have it as root 36 times 5. So we have it as root 36 times 5. And I can find the square root of 36, which gives us 6. So that is 6 root 5, all divided by root 75. Now this is what I'm thinking of, because I'm already seeing root 75 and I can see 15 and 5. So what I'll do, let's multiply 2 root 15 times 6 root 15. That gives 12 roots. Now 15 times 5, we know that's 75. So 12 root 75 over root 75. So I can easily do 75 takes away 75, and I'm left with my final answer, which is 12. So the final answer is 12. So I want to believe with this you are able to perform arithmetics on surds. We started with looking at how we can add surds, add 2 or more surds, how we are able to subtract, the addition and subtraction of surds, adding or subtracting 2 similar surds. Then we also look at how we're able to multiply and how we're able to divide surds. So with this, that brings us to the end of today's class. See you in the next class, where we'll be talking about rationalization, the conjugate and the rationalization of surds. Bye.